In this video, we're going to learn about the addition law of probability. The addition law is used for calculating the probability of the union of two events. So it goes like this. The probability of the union of events A or B is given by all this area that lies within A or B. Now, the way we can start out counting up all this area is just to take the area of A, the probability of A, and add that to the area or probability of B. But there's one issue with this formula as it is. That issue is that we're counting this overlap twice. We're counting it once when we add up the probability of A, and we're counting it again when we add the probability of B. And we only want to be counting it a single time. So what we can do is we can subtract off that area. This way it's only counted a single time. So minus the probability of that area there, the overlap, is the intersection of the two events. A intersect B. So there we go. This is our addition law of probability, and it'll be very useful in completing these problems below. First problem, suppose that A and B are two events such that probability of A is 0.3, probability of B is 0.2, and probability of A intersect B is 0.1. What is the probability of A union B? Well, to compute that, we can just use this rule. The probability of A union B is given by the probability of A plus the probability of B minus the probability of A intersect B. Probability of A, we're told that's 0.3. Then probability of B, we're told that's 0.2. And then probability of A intersect B, we're told, is 0.1. So putting this all together, 0.3 plus 0.2 is 0.5, then minus 0.1 is 0.4. So there we go, it's 0.4. Why don't we just double check this by visualizing what's going on? So here will be event A, and here will be event B. And now let's label with the probabilities. So probability of A intersect B is 0.1. That's the probability of where they intersect, where they overlapped. So 0.1 is what we put in the middle there. Probability of B is 0.2. So B already has 0.1 area in the intersection here. So the rest of it is also 0.1. So that way it adds up to 0.2. And then the probability of A is 0.3. So we've already got 0.1 in this intersection here, so the rest of it has to be 0.2 to add up to 0.3. Then once we add up all the probability contained here, all the area, we get 0.2 plus 0.1 plus 0.1, which is indeed 0.4. So yeah, checks out, makes sense. Okay, on to the next question. X and Y are two events such that probability of X is 0.5, probability of X intersect Y is 0.3, and probability of X union Y is 0.8. What is probability of Y? So again, we can use the addition law of probability, but this time we'll be solving for an unknown probability on the right-hand side. So let's write it out again for X and Y. Probability of X union Y is equal to probability of X plus probability of Y minus probability of X intersect Y. Alright, we're told that probability of X union Y is 0.8, so plug that in here. 0.8 equals probability of X, that's just 0.5. Then we've still got probability of Y, we don't know that, that's what we want to find, so leave that as probability of Y, and then minus probability of X intersect Y, and that is 0.3, so minus 0.3. Let's go ahead and simplify this. So 0.8 equals 0.5 minus 3, that makes 0.2, and then we've got our plus probability of y. So now we can just go ahead and subtract that 0.2 from both sides, and the result is 0.8 minus 0.2 is 0.6. That's what the probability of y is. So there we go. Probability of y is 0.6. Let's apply the addition law to solve a word problem. One card is drawn at random from a standard 52 card deck. What is the probability of drawing a heart or an ace? Why don't we start by writing down the addition law for this situation. Probability of first event is heart, so probability of drawing a heart, or second event is ace, drawing an ace. Probability of drawing a heart or an ace is equal to the probability of drawing a heart plus the probability of drawing an ace minus the probability of drawing a heart and an ace. Okay, so why don't we go ahead and compute these probabilities. The probability of drawing a heart. Well, the heart is a suit in the 52 card deck. There are 4 suits, the heart is one of those, and each suit consists of 13 cards. So 13 of those 52 cards are hearts. So the probability of drawing a heart is 13 out of 52. Alright, so how about the probability of drawing an ace? Well, again, there are 4 different suits, and each one of these suits has an ace. So there are 4 aces in this 52 card deck. Therefore, the probability of drawing an ace is 4 out of 52. Okay, so how about the probability of drawing a heart and the ace? This is really the probability of drawing the card which is the ace of hearts, the ace within the suit hearts. And there's only one of those cards, because each suit only has 1 card of each type. So 1 card out of the 52 cards is the ace of hearts. Now we can just go ahead and compute this. So 13 plus 4 minus 1. Well, 13 plus 4 is 17, minus 1 is 16. So 16 out of 52. Top and bottom are even, so we can simplify. We can divide by 2, get 8 over 26. Top and bottom are still even, so keep on simplifying. Divide by 2 again. So 8 turns into 4, and 26 turns into 13. So there we go. That is the probability of drawing a heart or an ace, 4/13. So now we know how to compute the probability of the union of 2 events using the addition law. In the future, we'll also learn about relationships between events, such as their being mutually exclusive.